Hi everyone, welcome back to my channel Learn to Understand, and in today's video we are going to continue the same topic in chemistry, and we're going to move on to the structures for these covalent bondings, these covalent compounds. Okay, so let's start. First, let me explain you about how the covalent compounds. See, because it's important to revise. So covalent compounds, they are formed because of the covalent bonds. Covalent bonds are also known as molecular bonds, right? Now covalent bonds are formed due to sharing of pairs of electrons, right? And let sharing of electrons simply. So there's a mutual sharing of electrons, right? And covalent bonds are of two types, polar covalent and non-polar covalent, right? So we studied about them. Now we are going to study the structures for these bonds. Okay, today I'm going to explain you the structures for these bonds, and I'll be using a red colored pen because that seems to be very bright. Okay, hydrogen molecule. As you can see in this image, hydrogen, it is having one valence electron, and we all know that hydrogen has only one valence electron. Okay, now the hydrogen molecule consists of H, right? Two hydrogens. So one hydrogen and two hydrogen, so these both combine together, they both share these two electrons and they form a molecule of hydrogen. The bonding that exists between them is single covalent bond. Okay, what is the bonding that exists between them? Single covalent bond. So I'll draw the electron arc structure for you all. Okay, see, first of all you should be clear with what you are understanding. You are understanding about covalent bonds. Okay, that means sharing. I'll show you. See, let's take that we have, no, I want this. We have one hydrogen atom that has one electron, plus you have another hydrogen atom that has another electron, right? This is the valence electrons, right? Now valence electrons means that they have only one electron in the valence shell. That is what is meant by the valence electrons, correct? Now if you see, this is an atom, this is the second atom, correct? They both combine. Now what happens is before combination. Now what happens after combination is this thing that is represented in the figure as well. They both come in mutual sharing. They both shares and they both complete the duplet and become stable, right? Duplet means two electrons in the valence shell. So they form a single covalent bond. This line that I've drawn, this represents a single covalent bond. Okay, now let's move on to the chlorine molecule. See, chlorine, let me explain you from here. Chlorine also has single covalent bond. We are talking about chlorine's molecule, thereby it is Cl2. It's mentioned here as well. So this is one chlorine atom. This is another chlorine atom. They have 7 electrons in the valence shell. As you can see, 2, 4, 6 and 7. So these combine together and they share these and become a chlorine molecule. I'll show you the electron structure. Then you will be far more clear with the thing. So let's draw the electron dot structure. First chlorine atom. 1, 2, 3, 4. Wait, let me see something. Okay. Yeah. So 2, 5, 6, 7. This is one atom. Chlorine atom. Plus one more. 1, 2, 3, 4, 5, 6, 7. Another chlorine atom. Right? These two, now you can see they're lacking one electron, right? So if this electron combines with this electron, then they both can be stable, correct? Now what happens is after combination, this was before combination, now after the arrow, that is after this arrow, after combination, what happens is, let me write that, chlorine 2, 4, 6, 2, 4, 6, one atom of this. Sorry for this, let me erase, people will get confused at what is she teaching. Okay, now they, as you can see, chlorine, two electrons come in the center and they both are going to share it. So we represent it by this, the chlorine. This is a single covalent bond that is present in it. What is this bond called? Single covalent, because they're sharing a single covalent bond, because they're sharing a single pair of electrons. That is, these electrons are being shared. Correct? Let's move further to the nitrogen molecule. Sorry, this should be nitrogen molecule. Okay. If I talk about nitrogen molecule, the electronic configuration for nitrogen is 2, 5, right? Means it has 5 electrons in its valence shell. So these are the electrons. I'm going to darken them up. 1, 2, 3, 4 and 5. Another, see, nitrogen molecule means N2. Then 1, 2, 3, 4, 5. They both combine and they form the molecule, and these 3 pairs of molecules they are going to share. So 3 pairs means triple covalent bond. TCB means triple covalent bond, and then form nitrogen molecule. Explain you. See, what is the electronic configuration? 2, 5. Right? So means if we draw 1, 2, 3, 8, 8. Let me erase these. Okay. Actually, erasing is very difficult in it, and I didn't realize. Okay. For nitrogen, now it is 5, right? 1, 2, 3, 1, 2. This way will represent. This is one nitrogen atom. Another I'm drawing 1, 2, 3, 1, 2. This is another nitrogen atom, right? So when they both combine, see, because both of them need what? 3 electrons more to complete their octet. Now they'll gain these 3 electrons. Sorry, this is 2, right? Let me erase it first. Okay. Now 3 electrons and 3 electrons. Both of them will form a bond together. Now what will that bond be? I'll show you. Right? I'll show you just 1 minute. Right. Then again 1, 2, 3 and 1, 2, 1, 2. This is the bonding. This is after combination. This arrow will represent after combination. Now what is sharing, I'll tell you that. Let me change the ink's color. See, this one will be sharing these 3, right? And this nitrogen atom is going to share 3, right? This way they come into mutual sharing. And when they enter into this mutual sharing, you all can see that what happens is they form a nitrogen molecule. And how is that bond represented? I'll show you that. N 1, 2, 3, and this represent triple covalent bond. Okay, what does it represent? It represents triple covalent bond. Correct? Let's move further on water molecule. See, water. What is the formula for water? H2O. Hydrogen positive, positive, oxygen negative. Right? Now, how is it negative? Whatever, we are going to study now. Electron dot structure for that. Right? Because that helps you understand clearly. For now, see, hydrogen has only one atom. Sorry, one electron. Right? Plus you have oxygen that has 6 electrons, that is 6 valence electrons, plus again one hydrogen that has 1 valence electron. So when they all combine, what do they form? They will group themselves together, they'll combine and they'll form water molecule, right? So you can see these have combined together, because see, oxygen wants to complete its oxide and hydrogen wants to complete its duplet, right? So when combine, what happens is, let's see that. They will, what will become as H. Wait, I'm going to represent the hydrogen's atoms, electrons by a cross. Let me just change it so that you all can understand what's happening. So I'm going to represent hydrogen by a cross. Hydrogen's electron by cross actually. This is oxygen's 2, 4, 1 it will be having here. X. What happened is, see, these 2 electrons, you can call these any 2 valence electrons, one each oxygen shared with this, one oxygen shared it with another hydrogen, and you can see this is the way they all bond, right? Now please don't be confused, I'll explain you the bond again. See, this hydrogen and this hydrogen, they want to complete the duplet, right? For completing the duplet, they will require two valence electrons. So when they require two valence electrons, this is the hydrogen's electron, this is the oxygen. So oxygen gave one to it, and formed bond. Oxygen requires to complete its octet. So when oxygen wants to complete its octet, then it requires 8 valence electrons, right? So 2, 4, 6 and 8, right? This is the way they form bonding. Let me change the ink color to red because that's the brightest according to me. Just a minute. Oh, I did it brown. Okay. Now let's talk about ammonia. What is the formula for ammonia? NH3. This is the formula for ammonia's molecule. Oh, this is the formula for ammonia's molecule, right? Now, ammonia molecule. Right, just a minute. Okay. Ammonia. It consists of nitrogen and hydrogen. Nitrogen has how many electrons? 5 electrons in its valence shell. Hydrogen has 1, 1, 1. So hydrogens need to complete the duplet and nitrogen wants to complete its octet. And in order to complete its octet, it needs 8 valence electrons. So if it needs 8 valence electrons, then what happens is it combines with hydrogens, right? And how it combines? Let's see here. So nitrogen has 5, right? 5 valence electrons plus it bonds with some hydrogens. Not some, actually 3 hydrogens. Okay. I will erase this for a minute and draw the structure here. This is nitrogen. Okay. Nitrogen consists of 1, 2, 1, 2, 3, 5 valence electrons. One hydrogen is here, one hydrogen here, and one hydrogen here. So they all combine. This is before combination. So what happens after combination is, I'll show you that. So in order to understand the bonding, see, this hydrogen completed its duplet, so it is stable. This hydrogen completed its duplet, it is stable. This hydrogen completed its duplet, it is stable. Now nitrogen wants to complete its octet. Now how is it going to complete its octet? Let's see that. So 2, wait, I'll change the ink color. It's not visible quite enough. Okay. 2, 4, 6, 8. 2, see, the hydrogens completed its duplet and nitrogen completed its octet, right? Because it required 8 electrons in the valence shell and it is done with it. So this is the way this ammonia molecule forms its bond. Let me go to red color. Carbon tetrachloride, that is CCl4. C for carbon, Cl4 for carbon, tetra. Tetra means 4 chlorines, right? This is the way it is bonded and it is a non-polar covalent compound. I hope so you all know it. Non-polar covalent means equal distribution. Let's see how. I'm going to draw the electron knot structure for it. Carbon. Carbon has how many valence electrons? It has 4 valence electrons because carbon is 2, 4, right? So 4 valence electrons. I'll draw those. Wait, let me do this cross for it. 2, 3, 4. Now chlorine has how many? Sorry. Chlorine has how many? Chlorine has 7 valence electrons. So 2, 4, 6, 7. 2, 4, 6. Wait, let me erase something. It would be better if you also draw it so that it's, or if you want to understand, you can. It depends upon you. that if you want to go side by side or you want to understand first and then do it yourself later, right? But please do it yourself. That's the thing I want to say, because if you practice yourself, then only it will be clear to you, or else it will not be clear to you. Okay, now 1 comma 2 comma 3 comma 4 5 commas. This actually not commas, using commas. This is electron. Okay. Now you have 4 chlorines. 1, 2, 3, and 4. Oh, sorry guys. Sorry for this. Right. Let me erase all these lines so that you all don't get confused. What is it? Okay. Now, if you see, this requires 1 electron. This requires 1. This requires 1. They both require, all 4 of them require 1 electron each. And carbon requires 4 valence electrons in order to complete its octet. So what happens is, let's see that. Now this chlorine, it uses this valence electron of carbon, means it shares it with them. This shares with this shares with this, and this shares this, right? So now chlorines are stable because they got one valence electron from, means they shared one electron from carbon. But carbon also wants to be stable. Now what will carbon do is, it will also do the same thing. It will take 1 electron from this chlorine, 1 from this chlorine, 1 from this chlorine, 1 from this chlorine, and included in it's all these 4 valence electron and 4 from each chlorine, 1 from each chlorine, that comes out to be 4. So 4 कार्बन के, 4 किसके हो गए, क्लोरीन के, तो कितने हो गए, 8 इलेक्ट्रॉन्स हो गए वैलेंस, and that was what was needed, right? So this way कार्बन का भी जो था ऑक्टेट वो भी कंप्लीट हो गया, एंड क्लोरीन का जो डुप्लेट था वो भी कंप्लीट हो गया. Correct? I hope so this thing is very much clear to you. Now let's move on to methane. Methane is CH4. What is methane? Methane is CH4, right? And again I'm telling you, methane is what? It is a non-polar covalent compound, right? What is it? It is a non-polar covalent compound. Now how does the molecule form itself? I'll show you. Just wait. Okay. Now let's see. Methane has, what is the formula? CH4, means 1 carbon, right? Let me draw the valence electrons for carbon. 1, 2, 3, and 4. And 4 hydrogens. 1, 2, 3, 4. I'm explaining you before combination first. This is 1 valence electron of hydrogen. This is another valence electron of hydrogen. 1 valence electron of hydrogen. 1 valence electron of hydrogen. Okay. So what happens is, let me change the ink color first. Yeah. So what happens is, carbon requires 8 valence electrons. I just told you right now. And hydrogen requires 2 valence electrons in order to complete its 2 valence electrons in order to complete its duplet, right? So if we see hydrogen shares this, then again hydrogen is sharing hydrogen. So all the hydrogens, they became stable. Correct? What did they become? They became stable. Oh shit, sorry. I'll draw it again then. Don't worry. Okay. So hydrogen was bonded, hydrogen was bonded, hydrogen was bonded, and hydrogen. Right? So carbon also did 4 and 1, 2, 3, 4. So 4 molecules of carbon itself plus 4 molecules from all these hydrogen makes it 8, and 8 valence electrons are complete. Right? So this way this methane molecule is formed. Now let's compare the ionic and covalent compounds. See, ionic is what? That are consist of ions. It is formed by transfer of electrons. Don't forget this thing. If I talk about covalent, on the other hand, it is sharing and polar, non-polar. We are going to read it, right? So no sharing of electrons occurs. So no directional bond. Don't understand what is directional bond right now. No particular, don't understand this here. So covalent compounds, electrons are shared, therefore directional bond. Don't understand. See, electrons are shared. In ionic, no electrons are shared. They are usually solid, that is, they are crystalline. They are highly volatile liquids or gases. They are not easily vaporized, but they are highly vaporized. Right? They are present in the fused state. Right? You should know that they are present in the fused state, and the these covalent compounds are not present in the fused state, right? Okay. Metal, they are melt to form a conductor. They are poor conductors. They readily dissolve in water. They are not readily dissolving in water. They form electrolytes when they are dissolved in water, right? They see now. If I talk about covalent compounds, they do not have any ion, so they are not going to dissociate into water. They don't dissociate into water, but yes, the ionic compounds, they do dissociate into the water, right? So this is to the end of the presentation. If you really liked my video, then do subscribe to my channel, do like the video, and if you really think that this content is helpful for others too, then do share the video and do press the bell icon if you want to get notified when I post a video. And thank you. Meet you in the next video.